video, I'm going to demonstrate some of the N7624B Signal Studio's basic capabilities to create and customize LTE waveforms to characterize the modulation performance of your components and transmitters. Error vector magnitude, or EVM, also called relative constellation error, is a key modulation analysis measurement used to quantify the performance of a digital radio transmitter. A signal sent by an ideal transmitter would have all the IQ constellation points precisely at the ideal locations. However, various design imperfections such as carrier leakage, low image rejection ratio, phase noise, etc. cause the actual constellation points to deviate from the ideal locations. In other words, an EVM measurement is a measure of how far the actual measured values are from the ideal locations. This measurement needs to be made quickly and accurately, and when testing transmitter components such as an amplifier, be accompanied by a clean test signal with enough EVM performance to provide an adequate test margin for the device under test. E-node transmitter conformance tests are carried out using downlink configurations known as E-Ultra test models, or ETM. These are highly complex signals due to the flexible nature of the LTE downlink or FDMA modulation scheme. Therefore, a large number of parameters need to be fully defined, which increases the chances of errors during setup. Signal Studio software N7624B eliminates this uncertainty and decreases the setup time by providing predefined setups for all three classes of E-Ultra test models. I am going to demonstrate how to create a test signal configured for an E-Ultra test model using this Signal Studio software for 3GPP LTE. Let's create a 10 MHz LTE FDD E-Ultra test model 3.1 downlink signal with the Signal Studio software. So let's get started. First, I'm going to set the basic parameters for the vector signal generator in the form of frequency of 2.14 GHz and amplitude of 0 dBm. Next, we are going to start with default basic LTE downlink carrier with fully filled QPSK 5 MHz 25 resource block signal, and we are going to modify that using the test model wizard. First, we'll set the system bandwidth to be a 10 MHz bandwidth, and we are going to go into the test model type, and here is where we can make the selection of E-Ultra test model 3.1. And as you can see here in this section of the graphical user interface, the different types of tests that this particular test model type is applicable to, you will find that EVM is one of the properties that can be characterized by this test model. The ETM 3.1 configuration is one of the 4 possible test models used for EVM conformance testing, and is the only ETM with all PRBs set to 64 QAM, which is the highest order modulation supported. We can see some of the configuration of how the resource blocks are allocated and the modulation type chosen by going and looking at the transport channel selection on the left hand side and looking at the DL SEH configuration, and you can see along the time axis we have 10 subframes, and along the y-axis we have 50 resource blocks, and they are all being utilized with a modulation type of 64 QAM. So with this setup, we can then generate our E-Ultra test model 3.1 downlink signal by clicking on the generate button, and subsequently, after the signal has been generated, we can then download that signal into a vector signal generator supported by this Signal Studio software package. So this concludes the demonstration of how to create a test signal configured for the ETM using Signal Studio for 3GPP LTE. Thank you for watching.